So, good afternoon, student. Our next topic,
Nothing, sir.
next topic that is Ethernet framing. So, Ethernet framing. When we are talking about the Ethernet framing, that means we are talking about the data link layer, because the data transfer in the form of frames in the case of data link layer. So that means now we are on layer 2. So now we are on layer 2. Layer 2, that means in OSI reference model. In OSI reference model, we are using layer 2 model, that is data link layer. Okay, next that is so in this case, when data transfer from physical layer to data link layer, then our Ethernet framing working. Because in physical layer, data transfer in the form of bits, then after that data convert into the frames. On that time, it use IEEE 802.3. So basically, these all are the standards. IEEE standards 802. 802 point that is specifically for the Ethernet framing, where when we talking about the physical medium, on that time we people use IEEE 802.3. When we are talking about the wireless medium, on that case we use IEEE 802.11. So when we are talking about the wireless medium, so that time we use IEEE 802.11. When we are talking about the Ethernet framing, for that means we are using IEEE 802.3. So next, we have the objective of this section, that is explain the application and references of the network. So what is the use of Ethernet framing? Why we are using framing? Why we use data link layer? Because when we are talking about a data link layer, that means our data plus there is one field. That field they contain the MAC address. MAC address of to whom? MAC address for source MAC address as well as destination MAC address. So these two types of MAC address that contain into the data link layer frame. So next we have the managing network communications. So we have 4 different types of a network. We can say that one is TCP/IP, second is ISO, third one is novel, and fourth one is IBM. So first we have that is TCP/IP. So TCP/IP is a we can say it's our implemented model. TCP/IP is an implemented model. OSI is TCP, OSI, and novel and IBM. So TCP is an implemented model. OSI is a reference model, that is specifically only for a reference. It is not completely implemented anywhere, but it is just for a reference model. TCP is a OSI is a layered number based model. OSI is a number based model, and TCP is not a number based model. OSI is having the 7 layers and TCP is having 4 layers. Novel that so first we know that what and why we use the protocol, because these all are the protocol. Why we use protocol? That means we have to some standards. We have to create some standards between 2 or 3 devices. When I want to communicate with other, so we must we misunderstand each and other. If I am talking in French, but you people are not able to understand the French language, so that type of communication is not worth. If you want to communicate worth. So on that time, you people need one protocol that take the standard in both sides. So suppose we want to communicate with two PCs, we need one protocol. We need one protocol. So most of the time we use TCP because it is implemented model. So OSI, then after that OSI. OSI is only for reference. That is not implemented. It is just for the reference purpose. Third, that is novel. So novel, that is another protocol. It's another protocol that used in 1980s, but not much popular. So similarly with TCP/IP, again novel. It's not a free of cost available. So TCP/IP is free of cost available for everyone. Next, that is IBM. So IBM that use this network for internal reference. IBM company that use IBM protocol for our internal reference, but for internal only. But when they want to communicate outside the company, on that time they also use TCP model. Or we can say that TCP is a completely implemented model. So next we have TCP/IP layers. These all are the TCP/IP layer. So TCP/IP is not a number-based model, as I told you earlier. So we can't say it's having the 4 layers: layer 1, layer 2, layer 3, and layer 4. On the other hand, OSI is a reference model, and it's having the 7 layers, and that is number-based model. So next we have the OSI reference model. So these all are the layers. These all are the layers that work from bottom to top. So from bottom, we can say that first layer, that is physical layer. Second, that is data link layer. Third, that is network layer. When we are talking about the physical layer, that means our data transfer in the form of bit by bit, bit by bit. And on that time, we need one physical connection between 2 or more devices. Second, that is data link layer. And data link layer, in data link layer, that is data transfer in the form of frames. Data transfer in the form of frames. On that time, we are talking about the MAC address. MAC address. And third, that is network layer. In the case of network layer, we are talking about the packets. Packets, as well as we are talking about the IP address. In that time, we must assign the IP address to a particular PC, whether our source IP address from where we are transferring the data. Another one is our destination IP address where we want to transfer the data, and data transfer in the form of packets in the case of third layer, that is network layer. After that, we are having fourth layer, that is transport layer. Transport layer, that means it maintains and manages the end-to-end communication. End-to-end communication. That means we have to use one protocol, whether we are using TCP and whether we are using UDP. Where UDP, that stands for user datagram protocol, and where TCP, that stands for transmission control protocol. When there is one question, that is when and why we use UDP, because we know about the TCP, why we are using TCP, because it is connection oriented protocol. We are getting acknowledgement from our destination whether our packet is completely reached over there or not. But in the case of question is why and when we use UDP. So UDP is a user datagram protocol. When we transfer the data as fast as compared to TCP/IP. Why we use? Because it is it's not sending acknowledgement to the destination. That is why it is faster. When we use our UDP, when we are on online, whether we are talking about online gaming, our same as it is our lecture is in the form of fast data transformation. We don't need any kind of acknowledgement requirement from the destination. So on that time we use UDP. So after that transport layer, we are having the session layer. So session layer that maintain the or manage the session, manage the session. After that, we are having the presentation layer. So presentation layer that contains the uh, encryption and decryption method, where we just format the data formatting. After sixth layer, we are having the final layer, that is application layer. And application layer, that means we are talking about the end-to-end communication. Okay, so we have next, that is the next one is encapsulation. So next one is encapsulation. So next we have the encapsulation part. Encapsulation part, we in that case we use from top to bottom. From top to bottom, that means we are talking about from application layer to onward. When we are talking about the application layer, that means we are talking about the HTTP, or HTTPS. Whether we are using secure hypertext transfer protocol or simple hypertext transfer protocol. So in that case, we have different data format here. So in the case of application layer, we have only data field, only the data field. In the case of application layer, only data. In the case of presentation layer, we have only data. In the case of session layer, we have only data. After that, transfer layer, we have data field plus another field. In another field that tells the source port number and destination port number. In the case of transport layer, in data field, in another field, this where are source and destination port number, another that contain whether it is using TCP or whether it's using user datagram protocol. After that, we have network layer. Data plus one field additional. That field contains the IP address. IP address for source and IP address for destination as well. After that, we have data link layer. Again, that contain data plus another field. And that field contains the MAC address. MAC address of source as well as the MAC address for destination. Last, that is physical layer. Again, that contain data, but data in the form of in the form of digital, because that is 0 and 1. Basically, in physical, that contain data in the form of signals. Okay, so after encapsulation, we have another process, that is de-encapsulation. So de-encapsulation, that work from bottom to top. That work from bottom to top. Encapsulation is top-down approach, and de-encapsulation is from bottom to top approach. So next we have the communication between two different, we can say that, different PCs, or we can say that end-to-end communication. So in that case, we just send the frame, and single frame, every frame, when we are talking about data link layer, every frame they have two different field. One is header field, and second one is trailer field. So frame, that means frame would have, in the case of data link layer, data link layer, network, and also have transport layer. Then after that, but packet would have only the header. Packet would have only the header, or network layer that transfer. So similarly, segment that transfer from session to upper layer. So all the layers are add only header, but data link layer add trailer field, and trailer field that contains the CRC, that is our checksum, that is specifically for checksum. And what checksum is doing, that is to maintain the integrity of the data. To maintain the integrity of the data. If error in data field and trailer field, have to find out the error. So next we have the frame format for whether it is Ethernet 2 or IEEE 802.3. So there is one field in both the cases, whether it is Ethernet 2 or IEEE 802.3. So before going to explain this, I'm going to launch first cool question for you. So this is our first cool question. So students, hurry up. So next we have the same format for whether it is Ethernet 2 and IEEE 802.3. So in the both the cases, there is one field from, if we are talking about from right to left. So in the case of right side, there is one term, that is FCS. FCS, that is specifically for frame checksum. And after that, we have data field in both the cases. Data field that contains the data. In Ethernet 2, we have another field, that is type. Type field. So this type field find that when you de-encapsulation on the other end, and so header it's one by one. So type field that indicate the what would be the next header layer, or what would be the next protocol. Then field value is the type of the value. Field value is the type of the value. So both are similar, whether we are talking about Ethernet 2 or whether we are talking about IEEE 802.3. So both are similar protocol, but Ethernet 2 is a more popular, and 802.3 is only the header network. So next we have the Ethernet framing. So in this case, we are talking about the because we already discussed about that. We have the type field, what it contains, So next, that is IEEE 802.3. So now 802.3. So in this case, we have the another field, that is LLC. So LLC, that is the logical link control that serves the access point, and it is doing mapping with the help of to help and control that contain 1 byte data, or we can say that 2 raised to the power 8 means 255. So now we have the length indicate fields. So length, that tells the indicates the length of the frame. Length of the frame, or we can say that means how much the size of data field and header field as well. So next we have the frame forwarding. So frame forwarding, that means we need MAC address of our destination where we just transfer the data. So we need MAC address for that. So next we have the Ethernet MAC address. So in that case, they just define the or specify the MAC address, what it is. MAC address is a physical address. MAC address is a physical address. Physical address means it is our permanent address. And MAC address is 48 bits that further divided into two parts, 24-bit and another 24-bit. And MAC address is located on the NIC card. NIC card, that means network interface card. So these two 24-bit and 24-bit, one is specifically for OUI and second is specifically for IANA. Where OUI, that is specifically that tells the organizational unique identifiers, that tells the vendor of the MAC address or NIC card. In second, data is IANA, that is specifically for internet access number authority. So in the case of Huawei, it has the fixed OUI number for Huawei product. In the case of Cisco, that slightly changes. In the case of OUI, means vendor, that can be changed in the case of Cisco, but in the case of Huawei, there is only one vendor. So next we have the Unicast frame forwarding. So the MAC address is also you can say that there are three types, or we just saying our frame forwarding in the form of three different field. One is unicast, multicast, and broadcast. When we are talking about the unicast, we have three different fields. One is unicast, frame forwarding, and multicast frame forwarding, and broadcast frame forwarding. When we are talking about the unicast, that means one-to-one communication. One-to-one. When we are talking about the multicast, one to many. When we are talking about the broadcast, means one to all. So next we have broadcast. When we are talking about unicast is specifically for one to one communication, where you are directly connected with your destination. Multicast means one to many, not all, but one to many. Next set is broadcast. Broadcast means one to all. When what is the best example for broadcast? Broadcast, the best example is when you don't know about your destination's MAC address. When you don't know about your destination MAC address, on that time, our switch, because switches are the smart devices, they just assign MAC address as a all F. In all the field, it assign the all F, all the field. So that all the fields tells the, that means your address is as a broadcast address. That means you don't know about your, you don't know the MAC address of your destination. Okay, on that time, switch, they just assign the MAC address as a all F fields. So this is another example of broadcast address. So next we have the multicast. Multicast means one to many, where you just transfer the data in to many, not all. Suppose we are having one switch, 24 port switch, and we just transfer the data to 10 or 15 PCs. You just select the IP address for that and transfer the data. So that is the example of one to many. We are not sending data to all the switches, all the ports that is directly connected with a single switch. So next we have the career sense part. So before start the career sense part, I am going to launch another tool question. I'm just going launching the next tool question. So next we have the career sense. So career sense is the new protocol that listen to an sense network signal on the medium that before transmitting the data or any data. So CSMA is implemented in Ethernet. So CSMA, that is career sense multiple access. So next we have the frame processing. So frame processing, that means we are just transferring the frame from one PC to another PC, where our checksum is there, type field is there, data is there, or MAC address is there. MAC address, whether we are talking about the MAC address of source as well as the MAC address of destination. So next we have the question answer that is related to your current topic. So first question, that is how does Ethernet that determine the protocol to which a processed frame that should be delivered? So correct answer for first question, that is your type field. So type field is the correct answer for your first question. Second is, how is it determined whether a frame should be processed or discarded upon being received by an end device? So correct answer for this, that is your FCS. So correct answer for this, that is FCS. So now we are going to start our next topic, that is based upon the IP address. Okay. So, okay, take care, students. Bye. If you are having any doubt, you may contact. Okay, thank you, students. Bye.